All right, so here are some of your skulls from the early primate fossil chapters that you're doing. So I just wanted you to see them in person and kind of also see them in scale. The first one that you have here is Egyptopithecus. He is called the dental ape. And that's because he's pretty small, right? He has a lot of primitive features, so you wouldn't technically look at him and think, wow, that's an ape. He has some very primitive features, including a little bit of a snout. Overall, his size is like a monkey, but if you do look at his dental formula, it's 2, 1, 2, 3, so that would be a catarrhine. And when you look at his molars, he has Y5 molars. Because Y5 molars are characteristic only of apes, he does have ape dentition. That's why he's called the dental ape. Only his teeth are ape, but the teeth are diagnostic enough that if you have an ape tooth, you are considered an actual ape. Next, we come to Proconsul. This is considered our first true ape. He's also going to be found in Europe. A little bit larger here. We can see full ape dentition. We can see very ape-like face. The eyes are forward. Everything's protected. It's prognathic. We have the 2, 1, 2, 3 dental formula. We have the Y5 molar. So here we really see all of his features are ape-like. Next, we move into Asia. We have Sivapithecus. Sivapithecus is this 8 million year old fossil right here. When we look at it and compare it to modern primates, we find that it's almost identical to modern orangutans. And so Sivapithecus is thought to be the direct ancestor of modern orangutans. Basically, this is an 8 million year old orangutan. If you take my lab, you will be able to compare this skull with an orangutan skull and really be able to see those similarities. And lastly, also in Asia, we have Gigantopithecus. Obviously, huge guy right here. Compared to all the other skulls, you can see how big he really is. He is considered the largest primate ever to have lived. He was over 10 feet tall. And I want to point out some specific features of his skull. Number one, you have this right here. This is called a sagittal crest. It is for extra chewing muscle, for extra chewing power. When you see this on a hominin, it shows that they chewed all day long, and it also shows that they had a pretty poor quality diet because they had to eat an immense amount of food. He also has a very thick, deep jaw with really big molars, and they're very worn down. This is also indicative of chewing all the time. He lived in Asia up until the time of modern humans, probably ate a very poor quality vegetation diet, and so he was just chewing all day long. But what happened is either humans hunted them because they were very slow, or climate change or human destruction of the plant resources meant that their diet went away. And when you specialize in eating a specific diet, if something happens to that diet, it usually means your extinction. All right, so now we're moving into the early hominins. So these are going to be the very base of the human family tree because these are all going to be bipedal. We're starting off with Sahelanthropus chadensis. His nickname is Chadman. He is the oldest or earliest biped, so he's going to be walking bipedally around 7 million years ago. As you can see, he has an ape-like face. He has a small brain, but because of his foramen magnum position and because of his small canine, we know that he was bipedal and he's therefore in the human family tree. Next, we have Ardipithecus ramidus. She's known as Artie. I have given her the nickname Great Grandma because she is directly related to the human line. So Artie lived around 4 million years ago. First thing you notice is even though she has a prognathic face, she has a very small brain, she does not have ape-like teeth. Those teeth are really small. She doesn't have the huge canine. She doesn't have the diastema, the gap to fit a really large bottom canine. They're really on their way to looking human-like. Her foramen magnum is directly underneath, so she is a biped, although she did have long arms and fingers and an opposable toe because she was also still climbing trees for safety and for food. Artie is going to directly lead to Lucy. If you look at both of them together side by side, you can really see that they're very similar. Lucy is about 1 million years younger. She's around 3 million years. She's the most well-known. Even though she still has the ape-like face, it's very wide, those teeth are human teeth, right? We don't see any large canines, no diastema. Still has a small brain, but Lucy is fully bipedal. The foramen magnum is directly underneath, but Lucy also has a spine, a pelvis, a femur, and a foot that look just like ours. She is completely bipedal, probably only going into the trees when absolutely necessary. So she's known as Lucy. I have given her the nickname Grandma because if this is great grandma, then here is grandma, and it's going to lead to us. Don't forget about the fossilized footprints, the Latoli footprints that also show that her foot and footprint was about 99% identical to ours. Next we have Australopithecus africanus. This is known as the Tong baby, and this is a very important fossil because when it was first discovered in the 1950s, we had been looking for large-brained ancestors. And when Raymond Dart started kind of getting this little guy out of rock, he thought at first it was going to be a chimpanzee. But he noticed that the teeth didn't look like chimpanzee teeth. And what really kind of unlocked the puzzle was the position of the foramen magnum. It was directly underneath. So the Tong child or Tong baby is what made us realize that when we're looking at human ancestors, we must look at bipedal ancestors and not those with big brains. We are not going to get big brains for a really long time, but we've been walking bipedally for millions and millions of years. So he was the key to unlocking what to look for in our ancestry. This Mrs. Pleiss is just an adult version of the Tong child, so you can see what they would look like when they were all grown up. Again, human-like teeth, bipedal all the way throughout the body, but still a small brain. Finally, we end with Paranthropus. Paranthropus is kind of a side branch on our family tree. They're kind of like a distant cousin, and part of it is because they have very extreme adaptations, much like Gigantopithecus, for a very poor quality vegetable diet. They have that sagittal crest that you learned about with Gigantopithecus, so they have extra chewing muscle. They have a very wide face, an extreme level of being prognathic. That face is very jutting far forward. They have very thick jaws, very thick, worn down teeth. All of this is going in the opposite trajectory than all of these other hominins. If these are going to lead to humans, humans have very weak chewing muscles. They do not have a sagittal crest. They have smaller teeth. We're getting a flatter face, a narrower face. In every way, Paranthropus is going in an opposite trajectory. So they are not considered a direct human ancestor, but rather a side branch that went extinct.